Hello. Thank you for being here. Welcome to our next session. Before I introduce our speaker, if you didn't get a chance to scan your conference credential on the barcode scanner by the door on your way in, please do that on the way out so we can have that for our metrics. With that in mind, I'd like to proudly introduce Ryder Selikow, who is a computer science undergraduate student at Lewis and Clark College in Portland, Oregon, and creator of the EduRange Cloud platform. Please welcome Ryder.
Thank you. Does this work? Okay. So as you said, thank you for that introduction. My name is Ryder. I go to Lewis and Clark College. I'm here with my professor, Jens, and a few students here to keep me company. So today I'll be talking about my work on EduRange Cloud, which basically aims to provide on-demand cybersecurity sandboxes using Kubernetes technology. So first, let's talk about what led to this. What was the problem this project aimed to solve? So traditional cybersecurity education often struggles with expensive, fragile shared environments that can create setup barriers and resource conflicts, which often prevent students from getting the essential hands-on experience they need for real-world scenarios. So what does that really mean? So we broke this problem into three main pillars. The first being setup friction. Complex traditional VM solutions often run into issues in classrooms where users often have many different types of computers on different chipsets, different OSs, which often leads to professors spending more time debugging and trying to help students get these labs running than actually teaching. And that's an issue. The second is resource conflicts. I've seen it myself in my own cybersecurity classes. All it takes is one student to think it's funny to drop the entire database of the SQL injection lab, and the entire lab is ruined. And in a cybersecurity class, that's bound to happen. The third is cost and infrastructure. Traditional solutions often are quite expensive and compute heavy, which makes it difficult, especially for smaller institutions like the one I go to afford. So our solution to this is a platform we call EduRange Cloud. EduRange Cloud is a Kubernetes-powered, cloud-based cybersecurity education platform and general framework. So EduRange Cloud aims to provide an educator or general customer everything they need for cybersecurity education. This is everything from realistic scenarios to complex classroom management tools to fully scalable infrastructure. Additionally, the project is fully open source, meaning you can host it yourself or pay for our managed hosting services. Additionally, we have full comprehensive documentation, and as mentioned, is fully open source. So let's talk a little bit about our design philosophy with this project. One of the core pillars of this project was that no local software installation should be required by the end user. What this means is when a student uses our platform, they install nothing. All they do is go to a URL on their browser, and using our EduRange web operating system, which we'll talk a little bit about more later, they're able to complete everything they need in the challenge, access all tools, instructions, hints, etc. So currently, we support three main types of challenges, but as we'll get into in a little bit, this is just kind of proof of concept challenge types. There's a lot more that we envision this platform being able to support. The first main one is fully virtualized OS. You can think of this as anything from as simple as a file carving challenge to something as complex as kernel level exploitation of an Unix OS. Our second is web security challenges. This is anything from containerized web servers or websites, so something like an SQL injection lab, to something more complex like supply chain attacks on web resources. The third and our newest is our attack defense scenarios, which you can think of similar to a traditional red-blue team, where we can have multiple different users in their own isolated environments, either attacking a single resource or multiple users defending a single resource. You get the idea. So one of the key things that makes EduRange Cloud unique from other offerings is its highly modular nature. What this means is that a specific customer can mix and match different components to create the product that is needed for them specifically and their need case. So for example, if one customer cares more about data, observability of the status of their students' learning, they can install additional modules around that need case. versus another user who doesn't need those modules, allowing us to keep resource cost and compute need down, basically eliminating a lot of the bloat that certain users may not need. So let's get a little more technical here and look at one specific part of the challenge or modular architecture of this platform, specifically the deployment of challenges. As we can see, we have three main stages here. The first is the blueprinting stage, where our CTD, or challenge type definition file, defines the general architecture of a challenge for that specific type. Then, from there, those definitions are extended by our CDF, or challenge definition format file, which takes those initial definitions and then defines the specifics for the challenge itself. This is things from questions, point values, scope, the apps available to the user, and all of that. Third, those two definitions are taken and deployed by our instance manager to create a challenge pod in our cluster. The beauty of this system is these are just two files. That's all it takes to define both a challenge type and a challenge itself. With the open source nature of this project, what this means is that users, educators, or anyone of that sort can easily make their own challenge types and challenges themselves. So I've said Kubernetes a lot. It's a buzzword used a lot today. But let's talk a little bit about why we chose Kubernetes, especially when it typically has an association with being more corporate and more larger code base oriented. So there are kind of four main technical benefits of why we chose Kubernetes over similar, more lightweight, in quote, solutions. The first is Kubernetes auto-scaling ability. Kubernetes is incredibly good at horizontal and vertically auto-scaling resources. And what this means is that our platform is able to function just as well with 10 users as it would with 1,000 users. Additionally, it's able to scale up between 10 to 1,000 users in a very short amount of time. I don't want to say specific numbers yet because I don't have exact numbers yet, but that is something we hope to get in the future. Additionally, what this means is that we can stay cost effective for users regardless of the size of the user base. The second is its self-healing capabilities. One of the key things we were trying to solve with this project is the fact that a lot of time in cybersecurity labs or computer science labs in general, a lot of time is spent debugging, fixing these complex systems, especially when things always tend to go wrong in these types of scenarios. So Kubernetes' inherent self-healing ability, such as its ability to automatically restart and redeploy resources that have errors, mean that the entire platform can continue running with zero downtime. And this is why Kubernetes is often chosen by many corporations. We use these same abilities in our platform to allow an easy and stress-free experience for educators. The third is the network isolation it provides. So due to how Kubernetes works, we're able to have very isolated virtual networks between containers in the cluster. And what that means is it allows us to have quite complex networking challenges without interference between these challenges affecting the networks or the virtual networks of each of these challenge groups. And finally, the modular architecture. Kubernetes by design is highly modular, which fits perfectly with our design philosophy of modularity. So let's talk a little bit more about the virtualization we're using. So for y'all who don't know, Kubernetes is basically a way of orchestrating a group of containers. Why containers, though? Traditional solutions often use virtual machines. That is usually considered to be the norm for such type of edu ranges. Well, the main difference between virtual machines and containers in this situation is virtual machines tend to have a lot longer startup times, are a lot more resource heavy, and have a limited server density, versus containers, which often have instant startup times, or near instant startup times, of course, are a lot more lightweight compute-wise, and allow for a way higher density per node. So why is this? If containers are so much better, why do virtual machines even exist? Well, there are benefits to a virtual machine, and the main difference between them is something called hardware-level virtualization versus operating system-level virtualization. We can see on a high-level view of the stack of a virtual machine versus a container that for each virtualized instance on the virtual machine, it is virtualizing a full Linux kernel, versus the container stack we can see that using the containerd runtime, we're able to have a shared kernel space between each virtualized instance. What that means is while the virtualization is technically not hardware level, for our use case, it allows us to have way more lightweight and efficient containers, and what honestly is what allows us to have so many containers running per user and still have it be cost effective. So again, for a lot of the technical architecture here, I don't really have the time to fully get into it. At the end, I will have some QR codes to our full documentation with in-depth explanations of all the architecture of this project. But let's take a look at a bit of a high-level view of some of the key components in this project. So we split up into these 3 key layers for viewability, the first being our user interface layer. So as you can see, the first part of our user interface layer is the student dashboard. This is the actual site where users, or the end user, the student, is able to join a class using a class code and then start up one of the challenges assigned to by their educator. From there, once they start up a challenge, they are taken to their own isolated instance of our EduRange web operating system, which again, we will get into in a little bit. From there, they can then complete everything they need for that challenge. Next, moving down to our core platform layer, we have a couple key components, the most important being our instance manager. You can think of the instance manager as almost the air traffic controller of our system. Basically, it's in charge of the resource allocation and resource orchestration of all challenges across the cluster. So this means it's in charge of creating, scaling, deleting, and all of that type of stuff of the different resources, specifically the challenge resources. Now moving down a layer to our Kubernetes infrastructure layer, we can see that we have this unit of challenge pods which contain individual containers within it. So this is one of the most key parts of this system. So let's talk a little bit more about what a challenge pod is. Excuse me. So it's a bit difficult to explain, what exactly a challenge pod looks like. Due to the CTD format we talked about earlier, the specific components within a challenge pod actually change quite drastically depending on the challenge type itself. What this means is, of course, a web challenge is going to look very different to a, penetration testing challenge. But to try to illustrate this a bit better, we have a diagram of a basic file carving challenge. We can see we have 3 main components within this. The first is our WebOS. This, again, is where the user actually completes the challenges, and it's exposed by our ingress controller to the wider web. The second is our remote terminal, which basically serves as a virtualized shell into our backend challenge. And the third is our challenge, which for a file carving challenge would probably be a containerized version of some Unix distro. Okay, so now is the time to talk about what the hell EduRange WebOS is. So EduRange WebOS is a fully virtualized operating system that runs in your browser. But that's not fully true, because what EduRange WebOS really is a fancy Next.js wrapper that runs on top of our Unix backend. So why did we do this? When protocols like VNC exist, that would have easily allowed us to pipe UI input from a Docker container to our browser. Why bother with this wizardry? The main reason for it, and again, one of the reasons why we're able to stay cost effective, is we don't have to render any type of UI or have any type of Windows Manager components on top of the Linux kernel. This allows us to keep our Docker containers lean and cost-effective. I know I've said cost-effective about 30 times, my apologies. But it basically is what allows us to keep the compute cost per user low. So, and what this does then is we still provide a familiar OS-like experience to users, especially ones who might have less experience in cybersecurity. I'm sure everyone can remember when you first started, and the terminal can be a little intimidating. So we still are able to give them a full desktop-like experience without the compute cost that comes with that. Another pretty awesome thing, in my opinion, about this approach is that because this isn't a real operating system, challenge creators have full control over what this interface looks like. So this means that for every CDF file, they define these specific apps, tools, commands, everything of that sort that are available and can be used in that environment. Additionally, thanks to our dynamic loading system, we are able to have users be able to create their own apps and have them be installed, like an app store, onto this WebOS. This means that challenge creators or educators can easily create their own new apps to extend the functionality of the platform. So here we have some examples of our WebOS running. On the left, we just have or the right, we just have a fun example of an emulated version of Doom running on the WebOS. And then here we have a more practical version of the cryptography tool, CyberChef, running on our WebOS. And the third component from that challenge pod, again, is the remote terminal. So the remote terminal is probably the easiest to understand of those. It's just a fully fledged virtualized terminal that runs as an app on the WebOS and allows native-like access to the command line of our backend. This means it behaves and feels identical to if you were on a native OS. OK, so we've looked at some of the weeds of it. Let's zoom out a bit and look at the complete user journey of a user using this platform. So a user first authenticates using an OAuth solution into our challenge dashboard. From there, they join a class and then select one of the challenges that have been assigned to them. Once they select a challenge, the challenge starts up and a pod is created. Again, that challenge pod is created for that user. Within less than 5 seconds on average from logging in to starting that challenge, the environment is ready and they're provided a link to a WebOS isolated instance for them only to complete that challenge. Once they complete that challenge, that entire environment is teared down and that resource is available to be allocated to a new user. So to validate this and to get feedback about how we can improve this platform, we ran some classroom tests last spring. Something to note is it was at my school, Lewis and Clark, which is a small liberal arts school, so our sample size was relatively small. We had 19 students for a networks and web development class. For our testing protocol, we had 3 lab sessions. Each was 1 hour long. The first was some simple SQL injection exercises. The second was some penetration testing with Metasploit. And the third were some more complex vulnerabilities around a couple privilege escalation. And for the assessment method, we gave a form after each of these classes and graded it on a 5-point Likert scale. So here we can see the data we collected from those responses. As you can see, the majority were quite positive. But looking at some of the specific anonymous student feedback we received, again, positives seem to revolve around people liking the general interface and flow of the platform. But more importantly, looking at the negatives, there seems to be 2 main pillars of feedback we received. The first is one that was relatively preventable. It was an issue of the challenge registry, which caused, on our first lab day, the platform to crash for about 10 minutes. That was just due to a mistake I made with some of the scaling logic, and it didn't scale correctly. But that has since been fixed. But as you can understand, there was some annoyance about people losing progress due to that. The second and more, one we should focus on more in the future is people found some of the instructions and the learning to be a bit confusing, and some of the challenges generally be too difficult for them. And that is definitely an area we hope to improve on in the future. So what's next? EduRange Cloud was my first big project I've built using Kubernetes, and I've been building it for nearly a year at this point. And due to that, of course, I've learned a lot through the process. And looking back at some of the early, specifically system architecture decisions I've made, there are a lot of things I would do very differently. So currently, I'm working on what I'm calling very creatively EduRange Cloud v2, which is a full from the grounds up rebuilding of the system architecture of the platform to improve a couple key areas. The first of this is having a proper CI/CD testing environment and pipeline. As you can imagine, for a project made by a college student, the current testing coverage is quite interesting. The second main pillar is cloud native architecture. There are a couple key architectural decisions that I'd like to change. For example, using a more unified API gateway, and most importantly, switching to a Kubernetes operator system versus the instance manager system for deploying challenges. And the third is a more security-first view of the design, taking more ideas from Zero Trust architecture into the general way we handle authentication. And for some target KPIs we are aiming for with this redesign, of course, an 100% authenticated endpoint coverage. The second, a 50% decrease in launch time for challenges. This might seem a little unrealistic, but initial testing using the new operator model and a couple more optimizations show that this should be possible. And the third is 80% or higher test coverage of the code base. Well, thank you for listening to my presentation. Right here, we have a QR code to view our full documentation site. And here you can view the current code base for the V1 version. Additionally, if you'd like to keep up with the project, you can either contact me or view our main site at edurange.cloud, and where is the best place to see updates as this new V2 version comes, and you'll be the first to know when we're ready to bring it to market. Thank you. I'll now take any questions.
So from the perspective of a test administrator for creating one of these pods, if you had an expected, let's say, 1 hour pod experience, about how much time would the pod creator have to put in, do you think, for something, that isn't overly challenging or, in depth, but an average investment to create something?
Got it. To make sure I understand you, so how much time would it take to develop a challenge?
Yes.
That would take about an hour. I think this is definitely an area we want to continue improving on and making it easier and easier till we get to a point where we almost have an abstraction like Lua, where it really is like a no-code solution. Currently, it's very similar to writing like a YAML file. So I'd say, of course, it depends on if you're doing a file carving challenge or some complex exploiting challenge. But I'd say definitely less than an hour. But I think it is hard to give an exact number because there's so much variation.
I guess the nature of my question is, let me rephrase my question. How much time has to go into creating what you're describing as the configuration from the tool set? So how much of the tool set do you have to sort of create the object of the object to lay out that challenge?
Got it. So very little. The goal, again, we're trying to abstract as much of that as possible. There is that functionality if you want to get in the weeds and really customize it. But for an average user, very little of that. It's all supplied to you as presets. We'll have all the preset templates for the types of challenges available. So very little.
Has the team talked about other applications in higher education, science classes, or anything other than cybersecurity?
Definitely. Yeah, that's a great question. We've definitely had some interest from other sectors, and we definitely do believe that this could definitely eventually lead to that application. Specifically, we've had some interest from the corporate sector, not only cybersecurity, but cybersecurity training for companies. And that definitely is an area that we want to move into. Unfortunately, I'm only one person, so time has been a bit limited, but we hope to, in the future, eventually expand to that.
Great presentation. This is a really cool tool, and it seems like a lot of good work has gone into developing it. So you were talking about the extensibility potential for it. Have you had enough people who have kind of sunk their teeth into it to create some plugins and share them? Like, do you know what the sharing platform of that extensibility might look like in the future?
Definitely, no, great question. And I'll be honest with you, no, we haven't. I think this version 1 was a proof of concept, and of course, I can say it's extendable as much as I want, but till we have real customers using it, it's hard to fully tell. So that's kind of the hope of this V2 is we'll get to a point where, because again, the V1, looking back at some of the code, I just don't believe it's something that could be continued for 2, 3, 4 more years. So hopefully with this V2, we can get to a point where we can really start introducing it to customers and then start to get some of that information. But at this moment, I can't say we do.
Since we all scanned in, you're going to let us know before you do an IPO, right?
Yeah, I'll be doing a pre-seed round now. 10,000.
Do you have time for a demo?
I don't have a demo ready now, unfortunately. I was thinking last night, I was like, I should get a demo running, but the server costs, I'm a student, so I try to keep those not running when possible.
So out of curiosity, you mentioned kernel exploits being potentially one of the exercises, one of the advantages for virtual machines is that full kernel isolation. So with Kubernetes and the containerization having a shared kernel, are you doing like nested virtualization, or how are you keeping those things separated?
I was hoping no one would catch that, to be perfectly honest. I chose my words a little poorly there, to be honest. That is one of the issues. I was at another conference in Belgium. I got into a good conversation with a professor out there about that exact issue. It's something we're exploring, and we have some solutions, but it's not fully there. I shouldn't have said kernel as an example, because that is, I think, one of the main limitations of containerization is kernel exploits. They can work, but they behave a little differently. So we have some ideas that we're currently working on, but it's not fully there. So thanks for catching that.
Yeah, no, it's very cool. Are you extracting that so the shared kernel is not actually what's being exploited then? Is that exploit's occurring off here in another container from the one that the user that's handling the user interaction?
Yeah, that's like one. We had two kind of approaches. The first is a pretty lazy one. We can also have virtual machines running in the cluster for that specific thing. You know, it's more resource compute, heavy, but for those specific challenges, it might just be simpler. But the other solution I've been exploring is, of course, an abstraction and some other techniques to try to make sure we're not allowing our users to actually exploit the container shared kernel.
How did you determine what options went into the base library of exercises, exploits?
If I understand your question, so like what specific libraries are available in each challenge?
Yeah, so you have a library of challenges that one can configure different packages to deploy. How did you decide what to put in that library for your initial release?
Definitely. So it was mainly focused kind of on the need. We did some tests in the network and web dev class, so specifically challenges were created for that. And beyond that, again, the version 1 kind of serves, I think, more of a proof of concept. I wouldn't be comfortable, having schools be running it without me there, at this point. So it really was like, how can we demonstrate the power of this tool? So a lot of those early challenges are like, look, this is really cool. We can show investors, we can show customers, be like, this is cool, we can do this. But besides that, they were more revolved around, okay, we have a networks web dev class, let's make a library of SQL injection exercises. With the red-blue team, it's like, this would be a cool way to show that this is something that other tools can't do. So we're going to create this as a way of showing, like, hey, look, we can do this.
If you went over this, I'm sorry. What's the financial model you guys are looking at? So down the road, if you start to take this market for, say, EDUs to take advantage of, would it be more subscription-based, a module-based, for instructors to create their own, say, exercises where they get access, but then the students pay for it? What's it ultimately look, or what's your guess to what you want to make?
I'm not sure if I'm at liberty to say that at this moment, but
Don't need exact numbers, but just like the style is more, like one-time, base price per organization, student-based.
I think we're definitely looking at, a tier model with subscriptions. But I think that's all I can say at this point. I'm sorry.
Okay, no, that's fine. Thank you.
I did notice it was open source. Would it be possible for people to run their own edge range clouds using their own Kubernetes cluster?
Definitely. Yeah, as it stands, it's, an approach of an open source where we can, if you don't want the stress of it, we can manage it for you. But if you're technically savvy and, you want to run it yourself, you have that option.
Got one more minute if there is another question.
Cool. Well, thank you for your guys' attention.